Hello, my name is Hitendra Patel. I'm the Managing Director of the Global Innovation Management Institute. I'd like to welcome you and join our vision and our mission of the Institute. Our vision is to democratize innovation everywhere, in organizations like universities or corporations, in high schools, in governments. And the idea is to unleash that creativity across the globe. Our mission is much more simpler: to train 1 million people worldwide, certify them, and unleash their creativity and their problem-solving skills to target any problem on this planet. The Global Innovation Management Institute has got certifications for individuals, for corporations, as well as for the government. And the whole idea over here is through certifications, people have the right to practice innovation. Through certifications, we create a roadmap for how to get better and improve as we get level 1 certificate to level 2 to level 3. We are today working with the Dubai government, the Qatar government, across Colombia, in Brazil, in the United States, helping these institutes and these countries become better in terms of their innovation journeys. We're working with corporations, giving them roadmaps, how they can go from level 1 to level 2. And we're giving certificates to individuals as they go from level 1, 2, 3, and 4 in terms of how they can actually innovate themselves, how they can innovate in teams, and how they can innovate in a company.
We've worked with several innovation consultancies, and we found the GIMI methodology to be able to help us democratize innovation very quickly across large groups of people.
Curriculum isn't enough anymore. We need to really be finding ways to expand the school into the community and bring the communities into the school. And design thinking and the GIMI impact model is what's going to help do that. I think that we really need to start looking for authentic, experiential learning opportunities for our students. And this is a really great framework that teachers can use that makes it easy to do.
The value that we see being part of the GIMI program is that we can offer capability building for students, for professionals, for corporations, and that's really exciting to be able to create a language that can help everybody connect with what strategic innovation is.
Today we've got 25 countries who are partners of the Global Innovation Management Institute. We'd like to see all 195 plus countries becoming part of this institute. So we are looking for training partners across the globe. We're looking for university partners in every one of those countries so they can be part of our network. And we would like to see companies and corporations around the world all embracing the certification programs of GIMI. And as a result, we can target any problem and we can solve any problem. Join us on our mission through certificates to give people the right to practice and a roadmap of how to improve.
Thank you very much, everyone. Welcome back, everyone, to our weekly exploration of innovation, GIMI Think Tank platform. I'm Erila, and I'm thrilled to have you join us as we continue our journey into emerging trends, best practices, and global innovation activities. Actually, as you know, one day of month, we are focused on the green, energy transition futuristic network that GIMI has created together with IXA Center. And we basically focus this day of the month on any knowledge or breakthrough innovation happening or any trends around the green energy and energy transition. So I'd like to leave the floor to your host for today, Carolina Chitiva, my colleague, to present the speaker and the topic for today. Thank you.
Okay, thank you very much, Erila, and thank you everyone for joining this session. As Erila mentioned, this is the session that we host every month, where we are trying to democratize the knowledge on energy transition. So we are inviting different speakers, different experts on the topic so that we can really understand how we can support each other, how we can share some knowledge and some tools to really make this energy transition happen. So regardless of the part of the world that you are located, I think this is a very exciting topic, but to make it real is a different kind of situation, right? So hopefully these sessions are encouraging you to pretty much take the lead on some of your industries, companies, or governments that you are kind of leading. and then we can support each other to really make this huge step in the world happen. So I'm very excited for the speaker that we have today. So he is Rafael Serpa. He is the leading sales team in Latin America of energy solutions at Newman and Esser. He's going to be talking about technology along the green hydrogen value chain. As you know, we have been exploring this green hydrogen ramp up in different sessions. So part of this goal today is that Rafael is going to be able to share what are those technologies across that green hydrogen value chain that will probably make that industry more efficient and pretty much happening. So just to give you a brief summary of Rafael, he is the General Manager of Sales and Applications at Newman and Esser in Brazil. Since he joined the company in 2012, he has led the strategic business in compressors, energy, and processes. Rafael is also a member of the advisory board of the Process Solution and Strategic Business Unit in the Newman and Esser group. And then through his career, he has been focused on project and business management with a special emphasis on the design, manufacturing, and negotiation of capital goods for the industry. Very interesting, his perspective and his experience. He has extensive international experience also in planning and conducting actions for team development, product and project management, market strategies, and relationship building. Rafael is also an active member of several professional councils and associations, including the Mining Council, the sector chambers of cement and mining, compressed air and gases of the Brazilian Association of Machinery and Equipment Industry, and the Chamber of Metallurgy, Steel and Mining of the Federation of Industries of the State of Minas Gerais in Brazil. So a lot of knowledge, a lot of connections, and a lot of networks that he has to be able to bring this knowledge that he's going to be presenting today to all of us. So thank you very much, Rafael, for being here. And now I'm going to give you the floor.
Thank you very much, Carolina. Thank you very much, everyone from the GIMI Institute and IXL Center. It's a pleasure to be here and to share, or try to share, a little bit of the knowledge I have on this very important subject, which is a part of the puzzle for the decarbonization of the industry and have a sustainable economy for the complete world, because this is our aim, right? We want to have a sustainable future for us and for the future generations. So let me share my screen because I have a presentation to support me. Let me know if it's
perfect.
Fair enough. So I want to share today a little bit about technology along the hydrogen value chain. So we're talking, there's an emphasis here on the green hydrogen value chain, but we know that hydrogen is more than just green, but this is the focus for today. And I want to talk a little bit about us, who we are. I was very well presented, thank you very much. But I also want to talk a little bit about Newman and Esser, just to give some context. I want to talk about the value chain for sure, some solutions, some practical examples, and just a quick outlook on what we are doing here at Newman and Esser. And there are some pillars, and I can say that these pillars are still under construction to support the industry for the decarbonization of our economy with hydrogen. And one of these pillars is technology, for sure. And I want to emphasize today the importance of technology along the hydrogen value chain, and that we cannot underestimate or underplay this big pillar that we still are constructing, as I said, and we need to reinforce if you want to be successful on this. Not only technology, for sure, but we need to look at policies, we need to look at finance, we need to look at qualification. So manpower, that's one of your big topics, and this is very important, and several others that we need them to grow together, so we have a very well built foundation for the decarbonization of our industry and economy. Newman and Esser, we are a German origin multinational. We are about 1,600 people working worldwide, qualified people working with a big focus on sustainability for our first solutions. We have 30 companies, 3 holdings, lots of countries, 11, 12, I think I lost count. And it's almost 200 years old group. So we were founded in 1830 almost 200 years, we saw some revolutions in the industry, and now we are facing another revolution in the industry, which is the decarbonization. So how Neumann-Esser can use this experience, this knowledge, and this continuity to support this new revolution we are seeing. And why H2? So we know that decarbonization is much more than just hydrogen. Hydrogen is just the focus of our presentation today. And why hydrogen? Hydrogen is very versatile molecule element. I don't want to go too much in details here because I think the audience or the participants are very knowledgeable too. But just to give a quick context. So hydrogen, again, is very versatile, very flexible particle, and it can be used as an energy vector, which is the big volumes you're talking about. It can be used as a fuel, and it can be used as a raw material in the industry. It's the most abundant element in the universe. So our sun runs on hydrogen and helium, and it is the element with the highest energy density, or the gas with the highest energy density that we can use in a practical way. And besides, on top of that, when you use hydrogen, you don't have CO2 emissions. So there are lots of other gases, other energy vectors that can be used instead of hydrogen, but many of them have CO2 emissions, and hydrogen doesn't have. So the emissions of utilization of hydrogen is just water and energy. So that's why hydrogen is very interesting. And how to produce hydrogen? So normally you need a process to obtain the hydrogen molecule. You need a source of this hydrogen, so where you can get this hydrogen from, and you need energy. And there are different processes, different sources, different energy sources, and you can combine them. These are just examples. There are more than just this which I'm showing. And by combining them in multiple ways, you can produce hydrogen as a gas. And depending on how you combine this source of energy, source of hydrogen, and the process, you have different colors. That's what how we are naming, how we are labeling this hydrogen molecule. And it's important to say that today, more than 95% of our hydrogen is the gray hydrogen, which is hydrogen which comes from the reforming of natural gas, fossil natural gas, with energy from a fossil source. So you have lots of CO2 emission, lots of non-sustainable cycles inside this production route. And it's important to see in this graph that this is not the only route. We have lots of alternatives. And when we talk about green hydrogen, which is one of the most promising ones, we are talking about electrolysis of water with renewable energy, mostly solar, wind power, and water, hydraulic energy generation. And this color is important for us to have this in mind, because what means in the end is what is the CO2 footprint of these hydrogen production routes, the impact in the environment of these choices that we do. So you might have hydrogen generation through all these routes, which are viable routes. They are all producing the same hydrogen, the same molecule, but you have to look what you're leaving behind when you use them. And you can have the CO2 emitting non-renewable routes. So as I said, the 95% plus of our hydrogen today is the gray hydrogen, which is the reforming of natural gas with non-renewable energy. You have CO2 neutral routes, but non-renewable. So for example, if you take the gray hydrogen and capture the CO2, you have the blue hydrogen as it's labeled. But this is not renewable because you're talking about natural gas, which is not which is a fossil source. And you have, of course, the CO2 neutral and renewable sources. So, for example, the reforming of bio hydrocarbons like bioethanol or biomethane, or you can also talk about electrolysis of water with renewable energy. So this is just to give a context on these technology routes which are possible and what to do with them. So today, when we go to the market, so when we go to the applications of this hydrogen, we see three main applications for the molecule. So it can be used as a fuel. It can be burned. It's a combustible gas. It can be used as an industry raw material. So you use hydrogen as a chemical component for the production of different elements in different industries. So, for example, we can talk about hydrogenation of fats to produce food. We can also talk about different chemicals or paraffins which are produced using hydrogen as a raw material. But also, we can talk about hydrogen as an energy carrier. And when we should focus a little bit on the energy carrier role of hydrogen, because this is the application where we will see the mega volume. So all the gigawatt, terawatt, hundreds of megawatt projects are focusing on production of hydrogen to be used as an energy carrier for the power-to-power application, to export energy from places where you have economic renewable energy. So you have economic hydrogen and economic energy carrier, to markets or to consumers which are deficient in energy production. So a very quick example, which touched me, I'm Brazilian. We in Brazil have lots of renewable energy generation. We have potential to generate even more, and we can export this energy using hydrogen as an energy carrier to Europe, which is deficient in energy generation because they consume much more than generate. And they also consume a lot of non-renewable energy today. So these are the main applications that we see for the hydrogen in the industry. And here we have the value chain. So just by looking at this picture, if you see any point of this map, you can already see there's a lot of technology and complexity behind. So again, we go back to technology. We have here the main pillars, starting with primary energy. So you need to generate economic, cheap, renewable energy to support all this value chain, because in the end, we're talking about energy. After you have the energy, which can come from solar, wind, hydraulic, biomass, can come from fossil sources. That's not what we want, but it's also energy. You can use this energy for conversion and processing. So you can convert this energy in hydrogen. And as I said, there are different routes for converting this energy in hydrogen. And after you convert this gas, hydrogen has a very high energy density, and it's very abundant, but it's a very light gas. It's a gas, the molecule is very small, and it's very hard to handle this gas. Besides being an explosive, it's combustible, it's also a very difficult to handle gas because of the size of the molecule. Then after you produce it, you need to store it up to the point that you're going to use it or transport it. And for storage, you have also lots of different technologies which can be used, such as salt caverns, which are common in Europe, or you can store it as a liquefied hydrogen. You can store it as a compressed hydrogen. You can store it as ammonia, which is one of the main routes which are being considered today. And again, lots of technology behind. And then you need to transport this stored hydrogen or this stored material. And then you have different routes also to transport, lots of technology behind. You have pipelines, you have ships, you have trucks, you have liquefied, you have compressed states of the gas, different. So technology behind all the way. And after you transport this hydrogen or this ammonia to the point where you're going to use it, to consume it, you need to reconvert it again to the final energy demand. So once again, we are talking about energy to energy, so always about energy. And in between, you have lots of complexity which need to be attended to. And you reconvert it for your final use, which can be power to X, whatever is your X in the end. So it can be mobility, you can use it for hydrogen mobility, you can reconvert it to electricity, to use electricity in now its several ways of application. You can use it for heating, you can burn it, you can use it again as a raw material of industry, or you can inject this energy back in the grid for the utilization where you have deficient markets in energy production. So different steps that the hydrogen has to go through before it reaches its final destination of final application. Lots of technology behind. And here we can talk about the practice. So lots of theory, but also you need to talk about the details. So when you are going to attend all these complexities of the technology before you reach your final utilization for the hydrogen, there's a huge industry behind. This is comparable to oil and gas refineries in complexity. And the requirements for defossilization of the economy are several. I have here just some examples. What is the discharge pressure of this hydrogen? What is the communication protocol to integrate all these technologies? What is the purity of the gas, of the hydrogen and the oxygen if we're talking about electrolysis? How are the energy disturbances going to affect the grid? This is a big question. So this is something that's popping up a lot recently. How the pressure disturbances are going to affect the different equipment. So one of the big steps in the hydrogen value chain is compression. You need to compress this gas for storage and transport. And you have this flow of the gas through the process, and you have different pressures along the value chain. How the pressure disturbances are going to affect these different steps. What about the water? If we talk about electrolysis, the water consumption is a big issue in many countries of the world. So you go to Chile, which can be a powerhouse for the world, and they want to produce hydrogen in Antofagasta, in Atacama, where they have lots of sun, but they have no water. Where did this water come from? How efficient is your water consumption and water generation? Safety, again, hydrogen is a gas that leaks very easily. It's a gas that explodes. So the safety standards change from country to country, from end user to end user, and this is a big discussion, and etc. I can go on here for many hours on these different requirements. And I bring this just to show that the industry is aware, the industry knows the complexity behind, and that this must be realized by everyone. So when we talk about policies, when we talk about finances, when we talk with the government, the banks, it's also important to make them aware that it's not so simple just to take energy, generate hydrogen, and use this hydrogen. That's lots of other points which need to be attended behind, and the technology industry is here for that. Needs lots of lots of knowledge, lots of qualified manpower. And some practical examples. So first we had the primary energy. You can see here in the bottom the steps from our H2 value chain. After you generate the primary energy, you need to convert and process. As I said, there are several routes. One of them is, for example, PEM electrolysis of water for generation of hydrogen and oxygen. And this is one of the examples that we have in Namanesia portfolio, that we are experts on this, to attending all these specifications, all this complexity that is behind such equipment. So the picture here just to illustrate is a PEM electrolysis module. This one is for 2 megawatt, just as an example, but they can go up to 5 megawatt and can be very modular and installed to attend the high demand of hubs, for example. So in Brazil, we have some hubs in the Northeast, as an example, and they are talking about hundreds of megawatts or gigawatts. How to reach these numbers? Because it's just not just about generating the electricity. You can have lots of wind turbines, solar panels to generate the electricity, but then you need to attend the hydrogen generation. And how do you reach gigawatt scale in these hubs? You need modular, simplified solutions that you can later on operate with a simple organization. And this is an example. So the PEM electrolyzers can go up to 5 megawatt in module. We can reach high purity because if the purity of the hydrogen is a big issue, and purifying this hydrogen is not simple, but doable for sure. And when you talk, for example, of hydrogen mobility, cars which run with fuel cells powered by hydrogen, they need 6.0, so 4 nines after the comma of purity of hydrogen. You need to purify. And also we can use the oxygen. Oxygen is more and more being seen as a commodity, not more as a byproduct to prevent it, but as a commodity to also help build up the economic model of this hydrogen generation plants with electrolysis. Another example in our value chain, we move from conversion and processing to storage. So again, we talked about storage. It didn't change the color, sorry, but we're talking about storage. We talked about salt caverns. We talked about liquefied. You talked about compressed compressed hydrogen. We talked about ammonia. And it's hard today to imagine a world, an industry, an economy without compressors. So we end users, we citizens might not see compressors very often, but they are everywhere. Everything that we have on site, on your desks or wherever you are, had the usage of compressors at some point. And this is the same for hydrogen. You need compressors for storage and transportation or reconversion of hydrogen in all its forms. And this is something, again, that cannot be underestimated. So we started saying that we cannot underestimate technology behind hydrogen. And technology behind hydrogen is not just generation. You saw the value chain. You cannot underestimate, for example, the compressors. Compressors technology, they are very well established. This is something that Neumann Esser, for example, does for more than 200 years. But just because it is consolidated, it doesn't mean that we should not pay attention to that, because it's a complex process with all its requirements, standards, and reliable technology is required here too. And then we go to storage. After you generate, you compress, you transform, you process this hydrogen, you need to store it, as I said. And here, just an example. You can store, for example, here, it's compressed buffers. This is a low pressure buffer between the electrolyzer, which is in the back, and the compressor, which is the blue one. We have this big vessel, which is the low pressure, and after the compressor, the bottles, which are upright, these are the high pressure storage hydrogen. So this is also another point in the value chain. Again, now it changed the colors. And we have transport and distribution and final energy demand. So here, just one example, again, back to the practical portfolio of Neumann Esser. You can have hydrogen as energy vector for mobility, hydrogen cars powered by fuel cells. And this, for filling up these cars, you need hydrogen refueling stations. So in these hydrogen refueling stations, you can have the hydrogen generation or not, but you need the compression, you need the storage, you need the dispensing. So effectively where you fuel the car with hydrogen. And again, lots of technology behind. And we are talking just about the gas. We're not talking about the car itself, because when you go to a car manufacturer, Toyota, Hyundai, the Chinese, Mercedes, BMW, lots of them, they all have also lots of technology behind their products, which are the cars. So this is an example of final use, but you have several of them. And here, just to give some practical examples, what is Neumann Esser is doing in our region. So Neumann Esser, Brazil, which is where I am, we are responsible for South America, Latin America, actually. And here we have some interesting projects which are running. So some practical ones, this is a project in the northeast of Brazil, in the energy company called EDP, where they use hydrogen to cool down their turbines. So as I said, hydrogen has different applications, not just an energy carrier. So they use the hydrogen to cool down their power plant. This is still the largest PEM electrolyzer in operation in South America, which was manufactured by us here in Brazil. Another example, this is a refinery of ENAP. ENAP is the state-owned petroleum company of Chile, and they are installing a hydrogen generation system inside the refinery to blend with natural gas, to burn this blend and reduce the CO2 footprint of their fuel consumption. So this is another example of utilization of hydrogen, using now this technology on board. Another example, hydrogen refueling station, which was just started up. This was the first Brazilian high pressure refueling station in Minas Gerais state, so my state, very proud of it. And this will be the first one operational for high pressure mobility with vehicles, not only small vehicles, but also buses, trucks, cars, forklifts, whatever we're talking about mobility. Here, another example. The first ones were industrial examples, so practical day-by-day use applications. But here we're also talking about new routes, so new technologies that we develop. This is a ethanol reformer, bioethanol reformer. One of the routes I've shown, which is CO2 neutral and renewable, is the reform of hydrocarbons, and bioethanol is a hydrocarbon. And you can take this bioethanol, which Brazil, United States, Indonesia, India produce a lot. You can reform this hydrocarbon, ethanol, into CO2 and hydrogen. You can capture the CO2, so you are even CO2 negative, if possible. And you can use this hydrogen, which is not green because it doesn't come from electrolysis of water, but it's a renewable and sustainable route also possible. This is the first ethanol reform in the world, which we are developing together with Shell. And the main application for this is a refueling station, so mobility again. But also this route of production of hydrogen can be used for all the typical applications of hydrogen. And another R&D example is a project that we have with Sinopec and Repsol, which is the production of green hydrocarbons. So when you have hydrogen, green hydrogen, and you have CO, not CO2, but CO, you can produce hydrocarbonates in a synthesis for these green hydrocarbons. And they can be used for several applications. You can use it for sustainable aviation fuel, lubrication oils, paraffins, green fuels. So you can build, this is the beauty of this project. With these reactors, this processing plant, you can build pretty much any hydrocarbon you would like to have in a green way, instead of taking these hydrocarbons from a typical refinery of petroleum. This is a very nice project. And we know about the importance of hydrogen in the decarbonization of an industry. And we also know that the technology industry, us included, we need to ramp up a lot and quickly to meet these decarbonization targets. And we believe in this ramp up, and that's why we're investing a lot. So just some examples of investments that we are doing here in Belo Horizonte, where I sit in Brazil. We are investing in the expansion of our facilities, which we are going to inaugurate this expansion still this year to produce more electrolyzers, compressors, and hydrogen refueling stations. We are also investing in our R&D center in São Paulo, also in Brazil, where all these R&D projects that I've shown are being developed and constructed, the pilot plants. We are investing in Germany, in our headquarters, so we are building a new campus, which we also attend the electrolyzer production center, but also releasing space for the ramp up of our compressor manufacturing. And by all that, we want to reinforce the importance of not underestimating the technology in the hydrogen economy for the decarbonization of our industry and society. It's not about only renewable energy. It's surely about renewable energy, which also has its particularities. It's not only about equipment, so the capital expenditure on these platforms, because afterwards we need to leave with these production plants after they are set. So in the beautiful future that we have in 2030, 40, 50, we have these huge hydrogen production plants, gigawatt terawatts of hydrogen being produced, and we need to leave with these production plants after they are set in the future. So we need to qualify workforce, which is, again, another very important pillar. We need reliable partners for the operation of these plants. It's not about just setting them up, it's to living with them, maintaining them in an efficient and economic production of hydrogen. This is the final message that I want to bring from all the presentation. And thank you very much.
Thank you very much, Rafael. Very interesting insights on the technologies that you have been driving forward to make this industry really ramp up. So let me ask just the audience to please share the questions that you might have on the Q&A button that you have in Zoom at the bottom of the page, so that we can definitely address those to Rafael. One question that we got already, Rafael, regarding your presentation is, we've seen like the different technologies that are right now being implemented based on what you just shared. But do you see any, let's say, close technology to be launched that is gonna, or that is focused on driving those costs down of the production of green hydrogen? And what are the main ones that you think that are gonna really make it happen? For example, we saw examples of people trying to use different materials for the production of green hydrogen of the electrolyzer. Will that work? We've seen some other, like using these electrolysis cells to be able to also decrease that cost. So do you see any of those technologies really happening to drive those costs down for the industry?
Yes, you can bring the cost down by two ways: improving technology, so being more efficient, and with scale. This is for sure. Have larger scale, you can reduce costs a lot. So when you talk about technology, there are lots happening behind the curtains. So what the market sees, what the newspapers show, is what is proven technology. And as I said, we are talking about complex gases, complex technology, and it's not very simple to develop and roll out these technologies before proving them. The validation, the technology readiness level of these solutions, they ramp up at its own curve. It's not very fast. So there's a lot happening. Yes, different technologies, different materials, different routes to process, but this need time. And to be honest, if we want to meet our targets of not heating up the planet or decarbonizing by 2040, 50, each one has its own targets, we need to use what we have available. We should not wait for the remedy which will come and be the solution for everything, because this will not come in the short term, and we need to start yesterday with these developments. So yes, lots of new technologies will come. They will reduce costs, but that's not the only way. Ramping up the scale of the actual technologies is the faster way, and we need both. We need to ramp up what we have, and we need to integrate what the new technologies that come along the way. There's no easy cut.
Okay, thank you, Rafael. Let's talk a little bit about the off-takers now. What are the main industries that you see, Rafael, like really leveraging this green hydrogen for their internal processes, production, supply chain? Which are the main off-takers that you've seen globally that are going to be able to really leverage this input, the green hydrogen, as part of their processes?
Well, the first off-taker, it's the closest one to us. So the substitution of gray hydrogen to low carbon hydrogen. So today we already consume lots of hydrogen, lots of gray hydrogen in the industry. So for the production of fuels, production of chemicals, production of food, and by substituting this gray to low carbon hydrogen, this is a quick decision. It's a technology proven route which could happen fast. What we have there is the economics barrier. So the stick that the economy handles, it's very strong. So why would a company change gray to green if green is 5 times more expensive? Who is willing to pay for the green premium? This is the challenge of this industry, and this depends a lot on the policies from the governments. So the policies of the governments are the only force which are strong enough to counterface the strength of the economics of this model. And they are coming up. So we see a lot of policies coming up. So first, this substitution of gray to green, it's the first obvious off-taker. And then you need the unavoidable. So Europe, Germany, where our company comes from, they need energy, and they cannot have access to easy energy where they are. So they need to import this energy through ammonia, for example, the most proven route. And I think this is the next closest off-taker. So the importation of ammonia, of energy through its carriers to supply electricity to these deficient countries. So there's two main off-takers: substitution and energy exportation.
Thank you, Rafael. Yeah, I think probably mobility is also one that is taking the lead in Europe, right? So all the different projects that we've seen in Europe are mainly focused on selling this green hydrogen for the mobility industry, either for trucks or transportation or aircrafts or things like that, right? So I think that's the other one that is pretty interesting to see how we're going to be able to make it cost effective for this type of industries. And then we've also seen, for example, the fertilizer industry, now that you're talking about ammonia, on how they might be able to use this ammonia, this green ammonia, to their processes. But then this is agro-industry. Margins are very low, so they need a very low cost to be able to substitute the energy they're using now for the green hydrogen. But I think it's a pretty interesting topic. Let me switch a little bit the gears in terms of what you mentioned regarding the policies and the support from the government. So we've seen different policies in Europe and mainly in the US and Canada, right? Just these governments trying to support the green hydrogen industry, giving some incentives and some, let's say, putting some drivers to really make this green hydrogen industry to be able to ramp up and, of course, to make those investments in a, let's say, accessible return, right, for the companies that are going to be willing to invest on green hydrogen. But then on the other side, even though this is one of the, let's say, of the key aspects or the critical aspects that we might need to be able to ramp up this industry, is that going to be sustainable, right? Because they are putting these incentives and these drivers to be able to support the industries to really invest on green hydrogen. But then will those policies and incentives be sustainable, and until what point, right? So at some point they will kind of need to stop providing those incentives, and then will the industry be ready at that moment to be able to produce the green hydrogen at a cost-effective way? What's your perception on that specific kind of support from the different governments around the globe?
It's a question where we want to go. We as a society, our governments decided that we want to have a future, which is a wise decision. And this goes through decarbonization of our industry. And to do so, we need a transition phase. We are talking about new technologies, new solutions versus a very consolidated technology and solutions, which is the fossil industry. And we are not talking about subsidies and policies to sustain something which is not sustainable. We are talking about levelizing the play field. So today, the fossil industry has huge amounts of subsidies and policies to support them. And don't get me wrong, we need them. This is a transition phase. We cannot snap a finger and change one technology to the next in 1-2 years. You need really to 2050 to transition from fossil to renewable. And so when we talk about policies and subsidies from the governments, it's just to bring renewable to the same level that we have from the fossil. They already are heavily subsidized and policy supported. So I don't see that this low carbon hydrogen is not sustainable, but it's not comparable to fossil because fossil has scale, which you talked about, and they are heavily subsidized and policy supported. That's what we are talking about, just levelizing the playing field. And yeah, this is a key decision where we want to go and where our policies, where we need to put our money where our mouth is.
Got it, Rafael. Thank you. I think that's pretty much the questions that we collected from the audience, Rafael. So any last word that you want to maybe share with the people that is joining the session, and then the ones that are seeing the broadcast also?
Yes, again, this is a very beautiful topic to discuss. So the sustainability of our future. And we at Neumann-Esser, our team, we are people behind this brand, Neumann-Esser, and we really believe what we are doing, and we are really investing our time and our days on developing these technologies to support this transition. Surely it's a business model, but also it's something that we believe on. And Neumann-Esser, it's as I said, it's a 200 years old group, We are a family business so far, so it's owned by a family. And to live 200 years as a family business, you really need to focus on what is sustainable, what is not destroying our midterm, long-term future. So us people behind Amanessa really believe that the technology that we are developing here to support this transition is something which is worthy of our time. And this technology that we are developing should not be understated in the hydrogen value chain, in the hydrogen transition, or to a green economy. And we need partners, we need everyone, all hands on deck to make this happen. And yeah, count on us.
Okay, thank you very much, Rafael. And of course, for everyone that is seeing this session, as you can see, Amanessa is one of the key players that is really pushing hard on driving the green hydrogen industry to ramp up and to really make it happen, to have a, let's say, a more green future around the globe. So thank you very much, Rafael, for joining the session. It was very insightful, everything that you shared. And thank you everyone that attend this session. So we will be sharing insights report after this session, and then we'll see us in about a month with another great expert and a speaker about the energy transition based on the network that we are driving from the IXL Center and the Global Innovation Management Institute. Thank you very much, everyone. It was very nice to see you all. Bye.
Thank you, everyone.